The tear film is a thin layer of fluid that covers and protects the eye. It sits atop the corneal surface, which is a rough surface made up of epithelial cells. Within the tear film, there are 3 layers: a velvet-like glycocalyx, which covers the corneal surface, followed by a watery aqueous layer, which is then protected by an oily lipid layer. When the aqueous layer becomes too thin, tear film breakup occurs. Tear film breakup is a common phenomenon associated with dry eye syndrome, which affects millions of Americans. Living with dry eye syndrome can be painful, but the condition is treatable. In order to better understand dry eye syndrome, ophthalmologists study the tear film through medical imaging. Such images can provide insight into the thickness of the film, giving us a better understanding of dry eye syndrome. In many images of the tear film, we observe patches of roughness, such as the area circled in this image. We aim to explore tear film dynamics in these rough areas. We hypothesize that the patches of roughness are evidence of tear breakup, and we develop a mathematical model to explore this possibility. Our model works in the following way. We simplify the tear film to one layer, the aqueous layer. This makes it easier for us to simulate its thickness, which is the desired variable. In order to capture the roughness of the corneal surface, we model it with a simple sine function, as shown at the bottom of our diagram. When our simulation begins, the tear film is at a healthy thickness, which we observe here. However, the film will thin over time due to evaporation. The model is programmed to run until the tear film is too thin, at which time tear breakup has occurred. Here's an example of what happens when we run our model. We can see that at the start, the tear film is the same thickness everywhere. But as time progresses, we see thinning in the middle. As it thins, the tear film remains smooth until we reach tear breakup. At this point, tiny bumps develop in the tear film, echoing the bumps of the corneal surface. Therefore, our model suggests that the roughness we see in images, such as the image on the right, are evidence of tear breakup. The results of our model will help ophthalmologists better understand tear breakup. It will also allow us to improve our mathematical models for the future.